Greetings, everyone. Let's do another video. Another medium problem, random medium problem that I haven't done before. Nope. Where'd my other tab go? Okay. New problem. There's so many just like array problems. Whatever. It's fine. It's fine. Let's do it. 15 minutes on the clock. Decrease elements to make array zigzag. Given an array nums of integers, a move consists of choosing any element and decreasing it by 1. An array A is a zigzag if either every even indexed element is greater than... I feel like this is a problem I've seen before. I gotta read this again. Given an array nums of integers, move consists of choosing any element and decreasing it by 1. An array is a zigzag if every even indexed element is greater than adjacent elements. Every odd indexed element is greater than adjacent elements. Return the minimum to zigzag. Every even index element is greater. So this is saying, okay, so A0 is greater than this, A2 is greater than this, and this. And in the opposite scenario, A1 is greater than this, A1 is greater than this. So, okay. I think I understand this. So it can't be greater than or equal to, though. So it's strictly greater than and strictly less than. And okay. I think this is fine. I think that makes sense. Return the minimum number of moves to transform the given array nums into a zigzag array. Okay, so we have 1, 2, 3. So let's do a little observation here. So we have 1, 2, 3. So we either want 1 to be strictly greater than 2, and 3 to be strictly greater than 2, or 1 to be strictly greater than, 2 to be strictly greater than 1 and 3. And so, okay, let's go with the even scenario. So we would need, for the even scenario, we would want 1 to be strictly greater than 2. So it would need to be 3, right? So it would need to be this next number plus 1. So, and that next number plus 1 is 3, and then 3 minus 1 is 2, so we would need 2 moves. If we look here, it's already greater than this, so we need 0 moves. And odd, we want this to be greater than this and this. And so in this scenario, we would need 4, because this is the maximum. 4 is the maximum of the greater element here and the greater element here. Okay. So but in order to get 4, we do 4 minus 2 is 2 moves, and then just 2 moves here. So, yeah, I think we can just do one pass through and update the odd count and the even count, where the odd count tells me how many moves I would need to make this an odd zigzag array, and then the even count tells me how many even moves I would need to make it an even zigzag array. Let's check on this guy. Hopefully this will give us a more interesting scenario. So for the even scenario, we need 9 to be greater than 6. So it needs to be 10. Wait, sorry. No. 9's already greater than 6. So, okay, so 9 needs to move 0 times. Now we're at the 6, so we want to go to our odd count. And 6, well, let's look at its neighbors, 1 and 9. 9 is the greater neighbor, so this is the one we care about. This is the limiting like factor here. And in order to get greater than 9, we need 10. And 10 minus 6 is 4, so we would need 4 moves here. Okay, now let's look at 1. We're back to even. So 6 and 6 are both the same, so we need 7. 7 minus 7 minus 1 here is 6. So 6 moves here. And now we're back here. And 2 and 1 are the neighbors. 2 is the greater neighbor. We need 3 to get greater than 2. And there's no point in me doing this actually because 6 is already greater than both of these. So we would need 0 moves for 6. And lastly, here, we would need 7. And 7 minus 2 is 5. So we need 5 moves. So we would need 11 to get even and 4 to get odd. Yeah, and then we just take the odd one. So this makes sense to me. Let's try this real quick. So we'll go odd, yeah, even 0, odd 0, odd num. Let's do for I in range. No enumeration this time. It's okay. So if I mod 2 is, so it's even and odd, and we're going to do so we'll get the left neighbor, and actually we can do this here. So left and right is going to be nums I minus 1, nums I plus 1, and this is if I plus 1 is less than the length of nums, else it's, can we have a negative numbers here? No. So, otherwise we'll just call it 0. And then over here we'll have if I minus 1 is greater than or equal to 0, otherwise it's 0. Okay, so now we have our left and right values. And now we need the limit, which would be like the max of left, right. Actually, we'll call this like need, because this is the max of our left and right plus 1. So this is what we would need. And so and now we would do count is equal to our nums at I minus the need. I'm sorry, wait, this would be need minus nums I. And then if count is less than or equal to 0, then we'll just continue. Otherwise, we'll left plus equals count. I'm sorry, this would be even plus equals count, or odd plus equals count. And finally, we'll return the minimum of even and odd. I think this makes sense. Let's check. Oops. All right, let's walk through this case here. So we're outputting 6. We only need 4. So evens here, odds here. So in the even case, we need to get to 8. 8 minus 2 is 6. Right? Yeah. So we're already greater than, so I'm assuming it's the odd scenario that we're going to need to pay attention to here. So let's just look at the odds. So 7 would need to be 11, right? So 11 minus 7 is 4. And now we look at 9. 9 would need to be 11. Wait. Oh no. Where's my code? Oh. Wait, we can only decrease elements. Yikes. I gotta read the problem better. Okay. That's fine, it's fine. We have to adapt. Alright. We can only decrease. And what was I doing here? I was looking for how many increases I would need. Okay. So we just kind of have to reverse the logic a little bit here. So So even an odd will actually be a little backwards because I'm now trying to minimize the even ones, which would be like here, a0 I'm trying to minimize this so it's less than its neighbors, a2 I'm trying to minimize this so it's less than its neighbors. But this actually corresponds to the odd index zigzag, but for this problem, even though it's backwards, it doesn't even matter because we're only returning the minimum number of operations. So I think it's fine if we leave it like this. So, okay, so instead our minimum, our smaller numbers are going to be the limiting factors now. So we want this to be like infinity actually. Like this will be like as high as we can get because we don't care about this. And so now the need would be the minimum of this minus 1, and the count would be nums I minus need, I believe. Yeah. And so if it's less than or equal to 0, we'll continue, otherwise. Okay. Alright. Yeah, not too tragic, but could have been bad if this was like a harder problem. Gotta read the descriptions better. No editorial. Hint. To each case. And say the even case you should yeah, I think that's what I'm doing. Alright. Cool. This is good. Alright, thank you for watching.